Okay, today we are moving on to 10.5, which is independent and dependent events. Okay, so this is the last section of our chapter. So next class we're going to review, and then next week you're going to have a test. So it's important that you guys are understanding how to do this. Okay? So compound events may be independent or dependent events. Okay? So remember, an independent is going to be someone that can do whatever they want, and a dependent, like you guys, have to rely on parents or guardians to support you. Okay, so independent means you do whatever you want. Dependent means you depend on someone else. Events are independent if the occurrence of one event does not affect the likelihood that the other will occur. So that means if there's two events, that means it's independent if the first one does not affect the second event at all. Okay, so you can see here, just like our other ones, we're going to be multiplying. So the probability of A and B is you multiply probability of A times probability of B, and the same with probability of A and B and C. You're just multiplying. Okay. So it says state whether the event is an independent event or a dependent event. You pull one marble out of a bag and then replace it before you pull a second marble out of the bag. Okay. So I want to think, how many outcomes do I have? Okay, so let's say we have 4 marbles in the bag. It says you pull one marble out of the bag and then you replace it. So since you replace it, no matter how many times you do it, you're going to have 4 marbles. So the first event is not affecting the second event, so it's going to be an independent event. The next one says you pull one marble out of a bag and then you don't replace it before you pull a second marble out of the bag. So when it says you don't replace it, if we're starting with 4, then we have 4 marbles, we take one out, and then we don't replace it. So now we have 3 to choose from. So that's why this one is dependent, because the first event affects the second event. Okay. So on this next one, it says you pick a red fruit snack from the package and then eat it. Then you pick a blue fruit snack from the package and eat it. This is dependent again because you take a fruit snack out of the package and you eat it. So you can't replace it. So the second event is going to be affected because of the first event. And then last, you flip a coin and then you spin a spinner. Flipping the coin has no effect on the spinner, so it is independent. Next, we're going to be finding the probability of independent events. It says, you spin the spinner and flip the coin. What is the probability of spinning a prime number and flipping tails? So, all I'm going to be doing is multiplying both of these probabilities. Okay, it's an independent event because spinning the spinner has no effect on flipping the coin. It doesn't matter. Okay, so if I want to spin a prime number, that is going to be a number that you can only divide by 1 in itself. So that means you can't divide it by anything else. So that's 1, 2, 3, and 5. 4 is not a prime number because you can divide it by 2. So the probability of spinning a prime number is 4 out of 5. So I'm going to have 4 over 5. And then the probability of flipping tails is 1/2. Then you just multiply across. So 4 times 1 is 4. 5 times 2 is 10. Then I can simplify. I can divide them both by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5. So the probability of spinning a prime number and flipping tails is 2 over 5. Next, it's asking, what is the probability of spinning a multiple of 2 and flipping heads? So a multiple of 2, that's 2, 4, 6, 8, 10. And on our spinner, we only have 2 and 4 that are multiples of 2. So that's 2 out of 5. And then we have flipping heads. The probability of flipping heads is 1/2. So multiply across. 2 times 1 is 2. 5 times 2 is 10. We can simplify both of those by 2. And we should get 1/5 as our answer. Okay. Next, we're going to talk about some dependent events, which the probability of 2 dependent events is the probability of the first one times the probability of the second one after it occurs, okay? So the only difference is that it says after A, okay? So because it's dependent, so that means A affects B. Okay? So in this first example, it says, people are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? So the first question is, what is the probability that one of your relatives is chosen first? So my relatives, I have 5 relatives and 6 friends. So I'm going to have 5 relatives over how many contestants or how many audience members, and we have 100. So we're going to start with 5 over 100. So that's my probability of A. Now I need to do times my probability of B after A. Okay. So now I need to find the probability that one of my friends is chosen second. So first of all, how many friends are with me? 6 friends. So 6 is going to go on top. Okay. So this is where it gets a little tricky because it's a dependent event, not an independent event. So one person has already been chosen from the 100 people. So that person can't be chosen again. So it's no longer out of 99 or 100 people. It's out of 99 people. And now we just multiply. Okay. So that's what makes it a dependent event, is that the first one affects the second one. That is what makes it a dependent event. So then you just multiply across. 5 times 6 is 30. 100 times 99 is 9,900. If you put that in your calculator, it should simplify for you. We're going to divide both of these by 30, just because I've already done it and I know that it equals 30, that they can divide by 30. So 30 divided by 30 is 1. 9,900 divided by 30 is 330. So that means there's a 1 in 330th chance that one of your relatives will be chosen first and then one of your friends will be chosen second. Flip your page over. Yes, we have 2 pages. It says, finding the probability of a compound event. A student randomly guesses the answer for each of the multiple choice questions. What is the probability of answering all 3 questions correctly? Okay. So, in this first question here, there are 5 answers. So the probability of answering this first one correctly is what? It should be 1 out of 5, because there's 5 answers, but there's only 1 correct answer. Okay. So then the probability of answering the second question is 1 over 5 as well. And then the probability of answering the third question correctly is 1 over 5. Okay. And then I just multiply it. 1 times 1 times 1 is 1. 5 times 5 times 5. So I know 5 times 5 is 25. And then 25 times 5 is 125. So the probability of answering all 3 questions correctly is 1 out of 125. Well, then it says, if the student eliminates choice A for all 3 questions, what is the probability of answering all 3 questions correctly? So, we're going to get rid of this one, and this one. So we'll just pretend the student knows that those are just wrong. Okay. So now, what is the probability of answering all 3 questions correctly? So the probability of answering the first question now is 1 over 4, because there's 4 possible answers, but there's only 1 correct answer. My probability of answering the second question is 1 over 4. My probability of answering the third question correctly is 1 over 4. So just multiply across. 1 times 1 times 1 is 1. 4 times 4 times 4. Oh gosh. We have 16 times 4 is 64. So, the probability of answering all 3 of those questions correctly after we eliminate the A's is 1 out of 64. Please let me know if you guys have any questions. I'm available during seminar or before school. Email me anytime.